Aloha. In measurement, one of the most popular approaches is the True Score Model, TSM, also known as Classical Test Theory, CTT. This approach traces its origins back to the measurement theory proposed by English psychologist Charles Spearman in 1904. The TSM is represented by the equation x is t plus e. Here, x denotes the observed score, which is fallible, t represents the true score, which ideally reflects the exact value of the respondent's ability or attitude, and e is the random error. The theory assumes that traits are constant, and variations in observed scores arise solely from random errors, which can stem from factors such as guessing, fatigue, or distractions. These random errors are expected to cancel each other out over repeated measurements. For instance, a respondent may occasionally perform better than their true score due to luck, while at other times their performance may fall below it. Over the long run, the mean of these measurement errors should converge to zero. When the error term is zero, the observed score equals the true score. Reliability in this context refers to the consistency and stability of observed scores across repeated measurements. If an instrument is reliable, it should produce consistent observed scores under similar conditions. Several widely used methods for estimating reliability, such as split-half reliability, Cronbach's coefficient alpha, test-retest reliability, and alternate forms reliability, are grounded in this principle. TSM can be seen as adhering to a simplistic version of realism in its assumption about the existence of a true score, or a single version of reality. This oversimplifies the complexities of human characteristics. For example, abilities may vary across contexts, situational factors, or fluctuate over time. Indeed, American psychologist Louis Thurstone highlighted that variations exist not only between individuals, but also within the same individual. Even if the true score exists in some realist sense, it may not be practically measurable, as all assessments are influenced by the choice of instrument, context, and interpretation. Additionally, Noel Wilson argued that the true score model is an only mathematical abstraction. Under this model, errors are indicated by the discrepancy between estimates, not between estimates and the hypothetical true score. If the true score doesn't exist in the real world and cannot be measured directly, the score should not be regarded as true. To rectify the situation, models like item response theory, IRT, Rasch modeling, or latent trait models extend beyond the simplistic realism of CTT. They recognize that measurement outcomes depend not only on the individual's traits, but also on the properties of the test items. Consider this scenario. If a person has a GPA of 3.9, does this number represent the true score? Is a student with a 3.9 GPA inherently smarter than one with a 3.7 GPA? Many people tend to treat these numbers as if they are absolute truths, relying on them for high-stakes decisions such as admissions, scholarships, employment, contract renewals, and promotions. This is problematic. Perhaps it is time to reconsider the philosophical assumptions underlying measurement. Thank you for watching.